Hey guys, thanks for joining me on the bench. I've got a small little GE that's showing up. I'll try to zoom in, capture a picture of the dial. It's a model HJ-514. I think it dates back to about 1940, 1939, somewhere in that area. It's a simple little 5-tube super heterodyne. Should be a quick, simple repair. Missing one knob. I'll see if I've got one that's matching. If not, I'll maybe cast one. For some reason, I think I've got some knobs just like this. Radio's pretty complete. One thing I did notice, that the tuning mechanism is froze up and kind of stiff. Probably just the dial string twisted up. You can see it just tunes part of the band, and it starts just north of 1110 kilocycles or so. So I'll have to fix that, but that's a simple repair. Here's the underneath label on the receiver. Again, it points to the simple design there, 5-tuber. Looks like powered from 115 back at that period of time. HJ-514, and we've got the tube layout as well. Get this thing apart. Let's take a look at it and see what it looks like. Hopefully it's not a mess. Good thing is, as found years ago, it's just been in storage. The power cord's been cut off, so hopefully no one tried to power this thing up at some point. A little bit of a conductor still attached to the antenna lead, and it talks about a beam, a scope must be removed to replace the tubes by removing 4 screws. So it must have been the nomenclature or the naming for the antenna, I'm guessing. Cool stuff that they did back in the day, how they named these things. Let me grab my screwdriver. We'll see what we got inside the old cabinet here that's definitely got some battle scars on it, you can see. It's always fun to look inside these things. Again, I think the fasteners they're referring to are probably these, have to be removed before the back panel here can be removed. Let me grab my well, I don't even need my nut driver. And just for reference, I think I'll go ahead and just clip these cables down here. You can see the one coming off of the tuning capacitor itself, going to the left side of the antenna. And then the remaining so that must be the beam scope. We'll look at the inductance on this as well, just out of curiosity, probably in the 200 microhenry range would be my guess. Looks like the receiver may be mounted on a piece of asbestos. I'm going to take this outside and remove this, not knowing for sure if that's the case. Just 3 fasteners here on the bottom. I think this knob just pulls off. There's no set screw. Yeah, I don't know the substance type there, but not to take any chances. I've just got a very wet, you can see, wipe that I'm going to use here just to wipe the chassis out where that made contact. And in addition, I'll do the same inside the cabinet, just wipe it down well, keep everything wet. And back in the shop now. Let's see, I've got the cabinet cleaned out well, about 3 or 4 times with some wet disinfectant wipes. This thing's going to be completely stripped. And I'll probably just go back with some stains instead of toner lacquers. We'll see when I get to that point. More of a two-tone finish. You can see the darker banding here on the bottom, and the other being your typical walnut, but it looks to be pretty solid. Again, your typical 5-tube layout. An old spider left behind. And you can see the model number here, HJ-514, A is an alpha. Just a few caps to replace, and some resistors, I'm sure, as well. And of course, get a new line cord on. We'll power this thing up with the Variac, of course, for safety purposes. And it should play again. Speaker cone looks pretty good shape. Place a piece of cardboard over the top of that while I'm doing the work on the chassis. Let's see what's going on with this dial cord. Oh, I can see. Somebody used a big piece of string to replace the dial cord. You can see how it's all knotted up down here. Someone definitely tried to make a repair. That's an easy fix when we get to that point. Let me get the spider removed, get the tubes out of the way, do a little cleaning on the chassis. And I was curious what the inductance of the loop antenna is, that being the secondary side, 221. And it appears there's a other winding as well for the external connection, probably a few turns, lesser inductance. Let's go to the antenna post, and about 3.18 microhenries and 3.3 ohms of DC resistance for the primary winding to inductively couple the antenna together here for a external ground connection, earth ground, and antenna. As you guys can see, the rear section of the tuning capacitor, or condenser as it was referred to back in the day, is the antenna section, and the oscillator appears to be the front section. You can tell more plates, larger capacitance range, a lesser capacitance range there on that front section. Let me hook up the meter at this point. There may be a pattern capacitor in place. I may not be able to read the true capacitance, but let me give it a check. And it looks like I just lost the spider. So somewhere around 515, 516 closed, and I cannot get back to the total open position, and we're about 65 picofarads. Probably bottoms out in the neighborhood of 15 to 20 picofarads. Get these tubes out of the way. The rectifier, 35Z5, most likely the audio, yep, 50L6. And the 12 SK7. SQ7. And the 12 SA7. I'll go ahead and cut this string that someone placed on here. And the tuning capacitor condenser is free. Looks like we are about 28, 29 picofarads. And max out around 500. Wipe a little of this crud off here with some disinfectant wipes just to see if we've got any surface rust. Looks like dirt, grime, dust that's accumulated. I think it's going to clean up just fine. Pretty cool All-American 5 radio. See if I can get the dial pointer off. The old dial pointer is stuck on there pretty hard. I'm afraid to pull any harder. You'll notice we have a spacer made out of cardboard. Grab my WD-40. Try the old glove trick. I'm using a 7mm nitrile glove. See if I can get that just a little tighter. Wow. That knocked the camera off the tripod. That thing was definitely on there. I'm lucky I didn't break it. They made that easy to remove. You can see the slots there on the stems for the tuning mechanism and the volume control. And the cardboard spacer. Just testing the output transformer, the primary side back through the secondary over to the voice coil of the PM speaker. Seems to be working. And so far DC resistance looks good on the IF transformer. Let's see, I'm testing the first IF right at 31 ohms. That's the secondary. Go back to the primary. And about 30 ohms. Let me look at the second IF transformer. I can see the lead wires are dry rotted, just like I found in the Grunow and many other receivers that I've worked on in the past. So we go back to the B plus side here, around 39 ohms. That's the primary side. See if I can locate the secondary side. And there we go. 31 ohms. So we're good there as well. I'd mentioned earlier about the old rubber wires used in the IF transformers. I'm going to go ahead and start with the first IF, snip it out, then rewire it real quick. And just for my edification purposes, take some time to document the inductance as well. And just for recall later, you can see the orientation of the IF transformer. Flip on the LCR meter, see what we read. Should be north of 1 millihenry. See if that's showing up there. 1.262 millihenries and just under 30 ohms of DC resistance. We know the IF should be set for 455 kilocycles or kilohertz. Let's do some quick math and estimate what the Q of the IF transformer would be. Let's check the secondary inductance and DC resistance. You can see it's almost identical, 1.263 millihenries and 30.3 ohms. There's a slight decrease in the inductance once I place this back in the shielded can. So again, we'll reference the numbers, but typically I see anywhere from 3 to 5% just due to the shielding. We'll see how this particular IF transformer is impacted, if any. Do a little cleaning. I don't want to make any adjustments to the IF transformer. Leave everything set where it's at, not saying it's correct. Let's flip on the LCR meter and recheck the inductance in the can now. You can see how shielding affects the transformers. And we're less, 1.170. Look back at my notes here. We were at 1.262 millihenries, so around 7%. Let's look at the secondary. And you can see the secondary winding is also less at 1.174 millihenries. And looking back at my notes, we were at 1.263. Just a demonstration of how the shielding around the inductors change the inductance. And you can see I polished up the chassis where I'll be placing the IF transformer back in, and did the same here for the IF can. Tuning capacitor is not in bad shape, but I'm going to go ahead and remove it. Run it through the ultrasonic cleaner. I've already made note the front section's the oscillator section, the antenna section back to the rear. It's always customary for me to check the tuning condenser capacitor here to ensure I don't have any shorts between the plates, and as you can see I do. When I get down to almost full capacity, I reckon there's just enough dirt and grime in between the plates. I'm getting a dead short, or one of the plates themselves are bent. I'll go ahead and get this thing cleaned up, and then we'll retest, see if that takes care of the issue. If not, we'll look to mitigate the issue. Let me move over to the front section and check it. See if we have any shorts there. And the front section, which is the oscillator section, looks good. So just the antenna section. Probably affecting the low end of the band. Let me see if I see anything obvious here. Just at a glance, it's probably hard to see on camera. Probably in this area of the tuning condenser. It looks like some of the plates are maybe touching. But again, I'll go ahead and get this thing cleaned up, and then we'll retest and then mitigate the issue, correct the issue. And just for reference, I'm going to go ahead and denote the capacitor with it fully open. Least amount of capacitance, of course, knowing that we have a short down in this area for both sections. In the trimmers, there should be a piece of mica that I'll remove and clean. So around 23 picofarads here on the back section, and the oscillator section as found right at 19. One piece of mica, and there's the second piece. I'll get those pieces of mica cleaned up again after cleaning the tuning condenser. I think I'll go out and spray this with the water hose, see if I can get the initial grime off before putting this in the ultrasonic cleaner for a few cycles. I'm going to go ahead and start the electrical restoration, getting these caps out one by one, checking the out of tolerance resistors. If I find anything noteworthy, I'll bring you guys back and let you know. This receiver also has this old nasty rubber wire in place. I'll inspect it closely. I can see a few places or a few lead point-to-point wiring that I'll need to replace along the way. Really nothing to report at this point, just what I expected to find. Resistor out of tolerance, and just getting these old wax caps out one by one. One resistor in tolerance. So all cleaned up and looking good, but I still got the short between the stator and rotor on the rear section, as you can see when I get down in this area. So we're good there. This area is where we've got the two plates touching. Let's fix that next. So for now, I've just got a little plastic shim. I'm going to use that and go between the plates, see if I can identify the shorted area. So I think my trouble is right in this area, right there. So there's the trouble spot. Let me just place that there. Try to hold the shim in place and rotate the tuning condenser through. So I think the plate is the second one over. Let me just see if I can bend it just a little bit. Well, that seems to have corrected it. You can see very little movement that I made. Well, we got that corrected. Let me check the capacitance across the entire range. And then we'll double check this again, triple check before I place it back in circuit. And before I forget as well, let me check the oscillator section. And capacitance, I think we're looking good now, right at 444 picofarads. And a min of 12.1. Now, if you guys recall, I've got the trimmer adjustments out, 6.3 to about 130. Let me get this thing lubed up here. Lubricated now. And it's free as a bird now. You can see I've got the meter hooked up and no shorts. Let me set this off to the side and get back on the electrical restoration. And I'll get this back in at some point here over the next day or so. Just a quick update. You can see I've got the first IF transformer back installed and the receiver. That's the one that has the new lead wire dress and just a few more capacitors replaced. My leave off point for now. I'll be right back and we'll tackle the power supply section and over on the audio output tube, get the tuning condenser or capacitor back in the receiver as well. So I can get the IF transformer out. I want to go ahead and get that second IF transformer out, and you can see for orientation of the can itself, put a black dot facing the rear, and there's the orientation on top. I'll look at the lead wire dressing as well when I pull this out. And with the rear dot here, you can see the orientation. The primary side here, secondary side at this location. Grid return B+, back over to the plate. As you guys can see, getting a little bit closer on the electrical restoration. Still got the IF transformer to rewire, put new lead wires on, and just give it a double check and get it reinstalled. A safety cap, get the line cord on, do some tube testing, and we'll be ready to power this thing up. As you guys can see, I've got the second IF transformer, the lead wire dress cleaned up on it as well. Let me go ahead and get it reinstalled. In addition, I've got all the capacitors replaced. In addition, all the resistors that were out of tolerance. I left 3 resistors behind. One is a little high, but I don't have the correct value. It's a little north of 20%. I'm going to let that be for now and see how it impacts the operation of the receiver, assuming it plays again. Let me get the transformer back in. Do some cleaning as well on the top of the chassis. Get the tubes tested, and we'll power this thing back up. Okay guys, I've got the second IF transformer back in. One goof on my part, you know. Mistakes happen, no big deal. My grid lead, I cut that wire just a little short. I forgot that I had left just a snippet of wire on this section, but no harm there. Let me get the tube sockets cleaned real well, and then just take my blower and blow up underneath the chassis as well. Make sure I don't have any fragments of solder or wire laying anywhere. And just do one more visual inspection. Then we'll test the tubes and go from there. For those that have followed my channel, I've had this big old container of deoxit for a long time. Just put a little bit on a brush not to reuse for the hummingbirds, and just go down through the tube socket, get these things nice and clean. Let me get the remaining tube sockets cleaned up. Just finishing up cleaning the tube sockets themselves. And one lead wire to install from the antenna section of the tuning condenser or capacitor back over to the antenna itself. I just grabbed a tube at random here, the 50L6. I already looked everything up to set my tube tester. Again, it has a filament of 50 volts. We'll look for shorts first. Let the tube warm up for a minute. Flip the lights off. We'll keep an eye on the short light. We may see a momentary short light. Now we can go into tube test mode. We just do a line test to make sure we're calibrated here. To the green, check amplification, and it tests good. We move this back to the GM location. It should read 7500. Let me increase my scale here. And we're in good shape. So it looks like our audio output tube is functioning correctly. By the way, a little oxidation on the tubes. I'll just take a Scotch-Brite pad and clean these, which I've already done, and spray the tube pans with just a little bit of electronic cleaner. Let me go ahead and get this back in the receiver, and I'll grab the next tube and repeat the process. Another at random, the 12SA7 GT, the oscillator converter tube. Looking for shorts first. Looks like this tube might be a little weak. We flip the light back on. You can see on the verge of good. Let's look at mutual conductance. I should read 750, and I'm just a bit north of 500. Put this one off to the side. I'll look for a sub for the 12SA7. There's another section as well. I'll forego testing that at this point till I find the donor tube that we'll try and see if we can do better than what we're seeing here on the tube tester. The 12SK7, the IF amplifier. Let me get that cleaned up as well. Filament at 12.6. $59.18 for the first setting. Make sure I'm in the short mode. let the tube warm up. Alright, looks like I've got a short right off the bat there. Let's see if there's anything noted here for shorts. It would be a negative. Now it's cleared up. I'm not going to take any chances with this tube as well. Let me look through my spares for another 12 SK7, the IF amplifier. Okay, we have the one remaining tube, the 12SQ7, secure at the base. Let me clean this real quick. Alright, let's test the 12SQ7 now, the detector, AVC, and first audio. Filament's correct at 12.6. 59.18. In the short mode. Back over to socket echo. Look at shorts, let the tube warm up. Another short there on number 3, number 4, number 5. So let me look at the notes and see if that's should be expected. That would be a negative. Let me shut this down and look for another 12SQ7. Let me get this tube back in the receiver, the 12SK7. Let me double check the 12SQ7 one more time. So we've got a short on 3, 4, 5. Testing 2 more 12SQ7s, 2 metal tubes. A short is also denoted on 3, 4, 5. The manual I'm referencing does not show that. You can see how easy it is to make a simple mistake. I was testing in socket E as in echo, should have been G as in golf for the 12SQ7. Let's look at shorts now on the original tube. Flip the light back on, look at mutual conductance. And we're about 1200 or so. Anything over 1125 is denoted as good. Let me check the other 2 sections. This would just be a diode test of the tube. Good there. And 7-1. And we're good there. Just getting the loop antenna back in place with the antenna connection going back to the antenna section of the tuning condenser or capacitor, and then what would be the circuit ground going back to this location, keeping the leads as short as possible, not to influence the tuning. And another look from a different angle. Just used a little WD-40, just a small amount down in here on the shaft itself, free as can be, and then cleaned everything off well with alcohol numerous times. Let me get some dowel string out and get the dowel cord in place. Just keep a miscellaneous box of springs and other miscellaneous connection items. I just pulled this spring out. I think that will serve me well based on the size of the pulley, and the dowel cord that I'll use is some I grabbed off Amazon a while back. It's a nylon 0.8 millimeter. It works really well. So I'm kind of guessing on this tuning condenser, most of these were the same when you have this type of configuration. Spring at this location, the dial cord will come back around this way and then loop clockwise around the shaft 2 to 3 times, back up and over and through. And usually there's a little catch here for tying the dowel string off. In this case, my guess, they went back to the same spring or a separate spring in one of the other cutouts. We start out here just by estimating the length of dowel string that we'll need. Just a little extra for the knot. I'm going to make a small modification to the spring on one end. Just put a little catch on it. Extend it just a bit. Grab my wire cutters and cut this here where I can loop it back through one of the holes there in the pulley. Loop this through a couple times here and just tie a knot. I'll tie one more knot, and then I'm going to just put just a little dab of super glue on the knot itself here. Let me get the additional knot tied in place here. Just placing a little tape there to hold this in place. Alright, I'll finish up here, tie this knot, then we'll test it out and see if this is going to work. So there we have it. I think that's going to work well without slipping. And if I still need to tighten this up just a little bit, I'll do so with the spring itself. Did you guys catch the mistake that I made? This section was supposed to go clockwise, and I had it going counterclockwise, so I've corrected that. Let me put the little spot of glue here on. Just cleaning some of the grime off of the dial scale, the back side. Another product that works really well, I've had good luck with on dial scales, the Renaissance Micro Crystalline Wax Polish. Just a little on the cloth here. Find a clean place here and go back over it. Ditto for the dial corner as well. This thing was on extremely tight. I think I want to put just a little bit of wax down in here as well. I've got the tuning capacitor fully closed. That thing definitely goes on tight. Get the dial light back in place now. Dial pointer's a little warped.
Those of us who are real close watchers of Joe Biden.
You can hear some of the electrical noise from the storm. After doing the IF alignment and the RF alignment, which is straightforward on these All-American 5 receivers, this thing is playing great. I also verified my B+ voltages and grid voltages. Everything looks fine.
Escape that fact, can you, Jim? Cut 23.
Is this the same Joe Biden that we saw?
I can hear the music. Maybe there's more intervention you've experienced. Maybe.
Hey guys, troubleshooting a noise problem, and it's coming from this area. I first thought it was maybe the volume control. Or, for those that followed the video, you guys recall I had a shorted tuning condenser or tuning capacitor. Anyway, the issue is really the metal dial scale. You guys can see the way that rests. They've got grooves cut out on the on-off volume control and the tuning knob. It appears just to be static electricity causing that. Even back in the cabinet, I've noticed the issue as well. Intermittently tuning or using the volume control, there's enough movement of the dial scale itself. The dial light itself is isolated from this, so I've actually removed it doing another test. Let me get that out of the way. I even ran a ground between the two. And between each one back to the chassis itself. Same issue occurred. I'm going to try to take some shrink tubing and place it around the shaft in this area. See if that isolates the issue. You may also notice I took a different approach on the dowel string that I shared earlier. A little bit of oil or grease was on the shaft here, so I just put a rubber grommet on, and I have the dowel string the same way, except for this one coming over and going clockwise. It's just counterclockwise. 2 turns counterclockwise back over and tied back to the spring. This seems to be more solid. Again, an example of the issue here with the metal dial scale. Anyone else out there experiencing the same problem with their model? If this doesn't work, I've got another idea. Let me power the receiver back up. Alright, it looks like I'm going to have to increase the size of my cutouts just a bit. You can see the metal compression ring. I'm going to put a piece of heat shrink over it as well, just in case it comes in contact with the metal frame. I just powered the receiver back up. See if this makes any difference.
James Franklin's done a really good job recruiting over the years. He's got that program back to where they're considered, one of the top teams in the country year in and year out, but their ability to get
just something to be mindful of if you guys have a similar model or the same model GE radio. Seems to be performing much better now. Again, if the dial face itself touches the speaker, we can hear some racket. That won't occur once it's back in the cabinet.
Oh, baby, you're just too blind.